me talk a little bit about energy and why, also in the context of energy, e-mobility is something that is very important. We try to peel the onion a little bit and trying to understand what's happening really in the world of automotive and individual transportation. And we discovered that in the long run, we will see a drastic systems change. And this is something that the automotive industry has not encountered in 100+ years since the first car was invented and built. And the reason for this systems change is actually, if you peel the onion, it's basically 4 reasons. The first reason is that we have very aggressive climate targets for the right or for the wrong reasons, but everybody's talking about CO2 reduction. And if you want to reduce CO2 across all the emittents that there are today by 80% to achieve the 2 to 3% centigrade goal of limiting global warming, then you know, the current combustion engines cannot cope with it anymore. There are physical limits. Secondly, everybody knows that oil is coming to an end. I mean, we have seen peak oil maybe, or will see it. Who cares? It doesn't really matter, but oil is scarce. It's getting increasingly expensive and increasingly dangerous to explore. So the oil reserves are coming to an end. And this happens in parallel with the rising demand for individual mobility in developing countries. Thirdly, more and more of the world's population will live in large cities, in megacities. There are different studies from IBM and the like. They say that about 75% of the world's population will live in megacities in 20 to 30 years. And especially for urban mobility, electromobility is the way to go. And then finally, when we talk about energy generation, I mean, you know, nuclear power is clearly something that is a technology of the past. And there are other ways to produce energy at almost marginal cost without CO2. You know, there are technologies like photothermal power stations, there's nuclear fusion, there's stuff that has not been really invested into over the last couple of years, although the technology is basically there. And it's actually a shame that it took us so long to define the first site for a nuclear fusion reactor, which now will be built in France. So if you put all these things together, then our standpoint is clearly that without the full transition to e-mobility, individual mobility will not be affordable and will not be accessible to the global population. Just a couple of data points here to underpin my arguments. This is just a quick benchmark of CO2 emissions of different vehicles that you can buy today. You know, the gray bars is the so-called well-to-wheel comparison, meaning that you know, from producing the energy, transporting the energy, putting it into the vehicle, and then driving, what's the CO2 emission? And you see that the most efficient cars that you can buy today have a CO2 of 130 plus grams per kilometer. The first e-car that you can register in Germany, the Mitsubishi, is about 20% less than that with our current generation mix. But if you look into the future, then you see that CO2 emissions will become increasingly lower because the generation mix will change drastically away from fossil fuels. And just take France as an example. It's a bad example now after what happened in Japan. But given their energy mix, such car would only emit 17 grams per kilometer. And this is less than you would emit when you ride a bicycle. You know, when you ride a bicycle, tank to wheel, you know, getting the food into your mouth and everything else, it's about 30 to 40 grams. So this is sort of what we're talking about. When you talk to the experts, you know, the next target that we will see in Europe, 95 grams, is something that is still achievable with current technology, but it's getting increasingly costly. The cost for a 4-cylinder petrol engine will rise by about 50 to 60% to cope with the 95-gram target. And getting below that, it's exponentially rising. So getting down to 70 grams will cost you about 3,000 euros per car additional cost. Now, fossil fuels, I mean, I don't want to bother you too long with that, but I think on the right-hand side of the chart, that is important. You know, assuming that in the next 30 years, the car density in countries like China and India will be at about 80% of what we have in developed countries today, would mean another billion cars being on the road. And this makes the point, I think, quite clearly that with fossil fuels, it will not be possible to power all these cars. What's also important to keep in mind is that there will not be one technology that will be winning in the short term. There will be a whole range of different technologies, and it's getting increasingly important for you as a consumer, but also for the OEM and for its suppliers to understand what is the car that you're driving really used for. You know, do you use it for inner city driving, commuter traffic? Do you use it for long distance driving? And how large and how heavy is the car? And depending on this, different technologies will be around for the next 30 plus years. And there's always a room up in the right-hand corner for highly efficient combustion engines with all the technology that I was just talking about, you know, start, stop, and variable valves controls and improved engine management and things like that. But you know, with the power of batteries increasing and with next generation of lithium-ion and next generation of new technology batteries coming, the hotspot for e-cars will increase over time. This is just a quick analysis of the different technologies, the different propulsion technologies, you know, across a set of criteria. And what you see is when you look at these Harvey balls is that in the short term, we believe that plug-in hybrid vehicles and range extender cars, so serial hybrids, are the best technologies. And in the long run, pure battery electric vehicles will be the winning technologies, but not with the lithium-ion batteries that we have in the cars, in the first cars today, but with next generation batteries, where a lot of money and a lot of brain power is currently invested into. Everybody's also talking about the cost of batteries, and it's interesting to observe this because the longer the industry is looking into this technology, the more confident the industry becomes that also batteries will follow more or less the same experience curve as any other component that you find in a car. You know, when you look at the first generation of ABS modules or ESP modules, they were quite expensive. They were introduced only in the luxury vehicles, but with the amount of these units being produced, the cost came down significantly, and the same will happen also for the batteries. And we strongly believe that within the next 4 to 5 years, there will be a break-even zone already achieved, and there will be quite a steep experience curve that you can observe. And just keep in mind what happened, for example, with flat-screen TVs. I mean, there were some geeks who bought for the World Cup 2002 flat screens about this size at MediaMarkt for 10,000 euros. Nowadays, 8, 9 years later, you get the same and even better technology for a fraction of the price. You don't have to pay more than 1,000 euros for such a device anymore. And this experience curve will also drive down the cost of batteries significantly. The major cost effect will come from mass production. We took different batteries apart and tried to understand, okay, what kind of raw material cost is in such a battery, what is the manufacturing cost, and so on. And raw material, there is some improvement potential, especially on the cathode of the battery. You can use cheaper materials, but you see the red part of this bar, of the stack bar. This is where really the economies of scale come into play. And this is why we believe that within the next 10 years, the cost to produce these batteries will come down significantly, will be only a third of what we see today. In addition, we should keep in mind that battery development, battery production is heavily subsidized across the world. Some economies, and this is just an example from the US, state of Michigan, if you like the heartland of the automotive industry in the US, the state of Michigan is putting, in terms of subsidies, tax advantages, $1.5 billion into a couple of sites together with industry. There's $2.5 billion invested directly by the companies. And this is happening around the world. You see a similar picture in China. You see similar pictures to some extent in Japan, in France, in Germany, not so far. What's also interesting to observe is that there are all kinds of new joint ventures, new cooperations taking place. Everybody is talking to everybody in all different shapes of form. New alliances are being built between OEMs, between battery manufacturers for the first generation of vehicles. And this is also why there's really a systems change happening to the industry, because important parts of the value chain are being shifted. It's not clear who will control which part of the value chain in the future, and it's a big challenge for a company like Bosch, but it's also something where they can potentially make a big business out of. But it's really not clear. The first generation of electric vehicles, the internal value add of the car manufacturers will be relatively high. You see joint ventures happening like between BMW and PSA, who said they want to build the entire electric drivetrain themselves without any suppliers. Whether this is the model of the future, we will see. But what's clear is that there will be new players coming into this value chain, trying to grasp a certain portion of the profit pool. More and more OEMs are getting bullish about sort of the share of electric cars being sold in 8 to 10 years from now. You know, between 5 and 15% is sort of the common sense of the industry. There are obviously variances. Toyota is very much focused still on the hybrid technology, whilst others like Renault and Nissan, they're very much focused on pure EVs. So let's see. As I said before, I think that all these technologies will exist in parallel, at least for the next 2 to 3 decades. But a lot of emphasis is being put into this technology for the reasons that I described before. The problem is really that you don't get any real products as of yet. You know, these are just some snapshots from sort of concepts that you can potentially buy. There are some sort of normal cars that are just being electrified, but these cars are not designed for electric mobility. They are standard cars where you just put an electric drivetrain in. It's not ideal. They're not optimized in terms of their balance, in terms of their weight. And the first serious products that you will see or that have come to market will come primarily from non-German, non-European OEMs, like the Chevrolet Volt or the Nissan Leaf. Mitsubishi I talked about. So the German OEMs who always claim to be the leaders in technology, Audi, Vorsprung durch Technik and so on, they are behind, I would say 2 to 3 years when it comes to serious production. They have all kinds of prototypes, they have all kinds of test fleets, pilots, but they are still a couple of years ago behind the other manufacturers, which may not be a big problem if they now come with something that is really innovative and they can really succeed with a fast follower strategy. But it is something which comes to mind when you look at this new technology, because typically this is not the case in the auto industry. Typically the German companies are driving the pace.